My name is Alexei. I'm the product marketing director at T Platforms. The company is actually an HPC vendor in the full essence of it. We don't do anything else but HPC. The roots are going back to 2002. It's a Russian-based outfit. It used to be, better put. Now we are expanding into Europe. What the company does is own hardware, own software, services, and turnkey integration. The idea is very simple. We think that HPC, especially at the higher end of the market, is a boutique kind of market where you want, as a customer, to have some differentiation and some customized approach each and every time. And that's what we're trying to embed into our strategy. Size-wise, it's I would say it's an innovation company. We are not big. We 160 people and quickly growing. Same stands for the revenue, triple-digit growth actually year on year. The way we try to cope with massive R&D and growth and sales office announcement, which is not just a sales office but also a qualification and assembly and point in Hanover. We try to use cooperations with scientific institutions or companies that are good at some kind of subject field. So currently, our flagship products that we are talking most of all here at the ISC 2010 is from the hardware side. It's a Blade 2 or T-Blade 2, the formal name. That's a HPC blade system. Very unique, the densest system on the market today, packing 64 sockets or 32 nodes into 7U. We also talk about Clustrix. We don't think there is a competition yet for that baby. It's a cluster-wide OS. If you think about the clusters today, most of them have some compute node Linux systems running, and then you need to put additional tools and modules just to make it a cluster. We decided to take a radically different approach to scale into petaflop level or exascale. Theoretically, I mean, it's too premature to say now, but still, we go in there. Imagine yourself a single family of code, if you will, the same basis, where you have everything from resource scheduler over to compute node, Linux, over to memory management, own version of MPI if required, manageability, single resource database, etc., etc. So it's a 5 years plus development. We've tried, I would say to an extent, it's a virtualized operating system that is trying to interpret the hardware inside the cluster as one single piece, as a resource available to you. We wouldn't call it a cloud, it's not, but it's a grid-ready system of a next generation that would actually dynamically allocate, or distribute itself, and would actually scale to dozens of thousands of nodes. So this is the part which is a software. We also have the manageability built in, so you can almost real-time track 12,000 nodes by one single 1U management node, and if you need more, you just add another node. All these things are good and well, but one thing customers require in many cases is turnkey integration. So when we walk into the customer premises, we try to analyze what the customer has, what the requirements are, and we build from scratch data centers. Not with all, internal engineering force. Of course, we have subcontractors, but we know what has to be done. So for the Lomonosov, that now fashionable word, which is everywhere at our booth, Lomonosov is a Russian founder of Russian science, so to speak. That's a Moscow State University cluster, which is number 13 today on the top 500. For that system, we had to move into the building, which was not a data center at all, and through the cycle of 1 year, actually develop from scratch a very tight data center where we actually pack 1.3 megawatts of power, having 4,500 nodes, having 420 teraflops at just 252 square meters compute floor space. It's a very, very tightly packed design. So we understand cooling, we understand, things like static electricity even, because you need to keep, the air, the humidity up. We understand the way actually to put infrastructure. The things we work now on is making a hot water reusable. We think about GPUs, and we now can tell you that we signed the development agreement with NVIDIA to have an access to their Fermi technology, and we're going to have a very tightly packed GPUs, Fermi, inside our Blade 2, having up to 106 teraflops per 42 unit rack, mid-term future. So all in all, one can ask, so how does the company do that all, having 160 people? The answer is simple. We're privately owned, and we're trying to work very hard with institutions out there, both on the governmental level and on also association level. We're trying to see what kind of prototyping we got to do, and we're trying to secure the funding as well. It's a cooperation kind of model we're trying to introduce and to sustain our development going forward. That would be it.
Very good. So let me ask you about one of these little canned questions, right? To someone who's never looked at T platforms before, if you could tell them 3 things, the reason why they should take a close look at T platforms, what would those 3 things be?
In order of priority is ClusterX OS being number 1 to enable the petascale computing. It's T-Blade 2 as a hardware basis that would actually even allow you to have, say, dozens of thousands of nodes based on that technology. Can I be a romantic to an extent? It's a passion. I mean, the company is crazy. Some people had said to us that we actually remind the Cray research of the earlier days. It's a company which is innovative, rather young, literally. We have the talent, 35 years old is the average age, and we think it is an advantage. We learn and we learn fast. So these are the 3 components. It's people as well.
So I'm glad you brought that up. Did they have like a top 100 or some kind of list in Russia, and how would your systems figure in that? Would they be the lion's share?
Rich, thank you for the question. Yes, we do. We have a top 50. The lowest system today, I think 1.5 teraflops. Ours is number 1, obviously 420 teraflops or 414 if we do not look at the cell-based systems that we also introduced some time ago. So if we were looking just at T-Blade 2 installation without heterogeneous nodes, it's 414 teraflops. To answer your question, there are, I would say, the easiest way to understand our market share is to think of the consolidated compute power of the top 50. And we have 50% of that compute power aggregated with our systems. What I also would actually tell you is that the reason we are expanding into the Western Europe and Central Europe is straightforward. For us to sustain the level of development we have, we need new markets and new users. We realized that we actually came to a saturation point on the local market. If you look at the IDC data last year, server shipments, we are number 3 after HP and IBM. Obviously, to an extent, this is this landmark deal with Lomonosov, this cluster, but still, that gives you, a feeling of where we are.
That's a great, yeah, that's a good perspective. So, if you had to look ahead, they're saying exaflops in 2018. So where do you see your company at that kind of time frame? Where do you want to be?
Let me be very reserved. My personal strategy always with customers or press, either to, just to, well, not to stay tight-lipped. Of course, it's impossible. HPC world is all about giving you, the sense of where we move. But we tend to underpromise and over-deliver. I'd say for us, the challenge today first is to make sure we are absolutely fit, we have good service network, and we actually can deliver the products the customers want. If we achieve that as a midpoint, we would need own interconnect, probably photonics, because we understand the copper is not going to bring us there. Manageability has to be, again, up to the grade. The parallel software, the efficiency of the software, of course. So it's the same kind of agenda most of the companies actually, look at. What we are trying to make sure is that we continue being a one-stop source. That's the way we think, future is bright for us, if I can put it this way.